Okay, today on the bench I have a 1500 watt inverter by a company called Traveller, and the model number, I think it says Intertech 3069523. I don't know whether that's the model number or what. I don't see a model number. 136 amps at 12.8 volts. So let's see what's going on here. I powered it up, or tried to power it up, and it was totally dead. And it's got 3 outlets, 120 volt outlets, a USB, and a remote on off, and a power switch. See how you get into this thing. Looks like, well, it's got screws on the end here, but I think I'm going to tackle this end first. Okay. I see a bunch of semiconductors down there, a bunch of fuses, 730 amp fuses, so that's 210 amps in fuse rating. Some rectifiers down here, some filter capacitors, some cobwebs, and not much else by the looks of it. Looks like this end cap will come away if I take these nuts and bolts out. Let me get some other tools. I'll be right back. Right, so let's put these pieces to one side. Take a look at those fuses down there. See what's happening. Yeah, all those fuses are blown. Every one of those fuses are dead, which means we must have a serious short on our hands. So let's see if I can check some more of these semiconductors here. So well, that may be shorted. That may be also. Oh. No, there's a capacitor charging up So maybe they're alright. Can't really easily get to the other side of this. Oh, they've got screws. That's what these holes are for, so you can get to those screws and separate the cover. So it looks like I'll do that next. More screws. Oh, interesting. I didn't realise the two halves came apart like that. This half should come off too. There we go. Well, that's a little easier to get at. Well, let me do a quick test from one side of the supply to the other, see if we've still got a short there. Maybe you can see that. Maybe not. Yeah, there's a dead short across. Oh, maybe not. No, it's a capacitor. Okay. There isn't a dead short any longer. Some the spider webs all inside here. Pretty crazy. Got a little brush, clean some of that stuff. All right, so what else we got here I can test? We don't have a short. We don't have a short anymore on the main input side, which I'm surprised. I would have thought something went short circuit, but depends what happened to this, because the fuses have all blown, which usually indicates there's a bad short on the chopper supply to the transformer for the inverter to generate the 110 volt, but it doesn't seem to be the case. The diodes, let's go to diode test. That's good. Good. Okay, I've just tested every diode here. All those appear to be, they all appear to be good. Let's go back to continuity and see what this says down here. That might not be good unless it's a capacitor. It could be across the transformer that I'm measuring. 0.2 of an ohm. And if I do that relative, it's a dead short according to the meter. See if I reverse that. Yeah, dead short. Another dead short. Yeah, I'm a little suspect of these guys here. Let's check the other end, the other side, see what they appear to be, whether they appear to be shorted or not. Bit tricky to get at without taking the board out, which I think I'm going to have to do that next. So there's a bunch of screws holding the board down. So 1, 2, 3, 4, at least 4 screws holding the board down. So let's pop those out so we can get underneath the board, do a bit more investigation. Now we're free. Okay. And more spider nests. So let's get underneath this board, see what we've got. Okay, so several of these devices are connected up to these diodes. These diodes appear to be okay. I would imagine they're also connected up to the transformer, which is here, and well, one side is here, the other side is here, and looks like these are gate. This is probably gate for this FET. Let's see what we have. That looks like it's shorted always. Yeah, that's a dead short. Dead short. 1.7 ohms. 1.1 ohm. There's about 8 ohms across here. I'm getting a short across this device here. I thought it was. Yeah, both ways. That's reading a short. I don't know how you're supposed to get at that FET, because this little daughter board is blocking it, which is pretty crazy. I mean, you can't unscrew it without taking this board out. I guess I could unsolder everything off this. That might be the way to do it, actually. I think there's a heat sensor here. Probably shuts it down if it detects it gets too warm. Yeah, I think the way to deal with this is actually take the whole unit, the whole heatsink off the board. In other words, unsolder all these 4 devices, lift the whole thing off and undo those 2 screws. Not sure whether I want to try powering it up, just out of curiosity, just to see what happens, if it just shorts out or what it does, which it probably will. Yeah, I'm tempted to put just one fuse in here, just one fuse, and seeing, you know, if it will power up or not, which I suspect it won't, but just for giggles, just in case I'm measuring across a transformer or something here. It doesn't appear to be shorts on these devices, which is a good thing, because this would be on the primary supply, and I know the fuses are blown, so I've got to replace these fuses, which I do have replacements for all these. You know, then I'll just replace, you know, maybe one fuse and see what happens, and power it up off my bench power supply. Obviously there was a big short at some point that blew all these fuses out, but you know, it's difficult to tell what went short circuit, you know, because it may have been, oh, what we got down here apart from corrosion? Oh, it's the buzzer. Wow, there's a lot of corrosion all over that. Let's clean that up for a start. Yeah, that's better. Because these fuses, obviously they're designed to blow if there's an additional or too big a load from the battery, and they're designed to blow and protect whatever's you know, connected battery or whatever. And they've all blown, and that input comes over here and the other side comes this way, and I'm assuming chops up the DC with the FETs on this side of the board, because the rest is, it's opto isolated, so unless the load is excessive, these fuses would have blown because of a short on this side of the opto isolator, which is sort of here. So the transformer is meant to isolate the two sides of the board, and the opto isolators just feed information, status of the unit. So I'm going to try and desolder that one, and maybe put one or two back in their place. Let's get some fresh solder on there, I think. Some fresh solder. Yeah, it sucks all the heat away from the joints here. All the metal here, it's sucking all the heat away. So it's not going to be very easy to desolder these, but yeah, I think I can. I think I'll be able to do it with the heat cranked up a bit. I could cut them out actually. That might be the easier way to do it, is just clip each one right out the board. Yeah, that's what I'm going to do. I think it's going to be easier to just clip each one and then take out the pins that are left. So let's do that. There's one. They got little looks like little asbestos sleeves that sit on each one of the legs. This one must have created quite a spectacle when it went off, I would imagine, when all these fuses blew. I believe what happened was it was connected up back to front on the battery, which, you know, is it's not a good thing, but I think that's probably what happened. See what I can do now about getting the rest of these fuses out of the board. There's one. This might be a bit more difficult because we've got this big connection on this side, which I might need quite a bit more heat. Might have to use a different method for removing these and soldering them back. I think they might have used lead-free solder as well. Alright, I think I pushed them all out of the board. I think I might have to get the desoldering gun on these. Some have actually, looks like some have dropped out. And the rest need to be removed. That terminal's getting pretty hot. Well, finally got all those fuses out of there, and now I need to clear up these holes with a solder sucker. Well, the MOSFETs have arrived, and looking at the data sheet for these, they're 50 amp 200 volt MOSFETs, N channel, and they'll handle a 200 amp surge, which is quite surprising really, considering the size of them. But anyway. But anyway, we can replace the faulty ones and put it all back together and give it a try. I noticed that the one half of this heatsink, which is isolated in the center here, I noticed that these two are insulated from the heatsink and these two are not insulated from the heatsink. So it's a good job I marked this so I know which way around. So this goes closest to the front of the unit. So this side is non-insulated and this side are insulated. So let's get to replacing these. I'm going to replace all four. I think it's easier just to replace all of them, and I've done with it. I can do a quick test as well, just to make sure it's what it's supposed to be. I got these, I ordered these from Amazon, but you never know whether you're going to get fake components. Yeah, N channel MOSFET. Yeah, okay. Gate drain source. Put a little bit of heatsink compound behind each one as well. There's 2 replaced. Those are the non-insulated ones. Let's do the insulated ones. Well, that one doesn't want to come away. See if I can persuade it to separate. We've got it. There we go. A little bit more heatsink compound. Not going to put a lot on that one. Somebody on YouTube always refers to the amount of heatsink compound as just the right amount. So I just added just the right amount. Okay, and I'm just going to check that these 2 are isolated from the metal, from the heatsink, which they are. And this one yeah, both of those are connected to the heatsink, which connects to the printed circuit board underneath. So we're now ready to put this back into the board and maybe give it a try. Now it's that way around to the board. Just line this up. You've got to put that heat temperature sensor in the right place as well. That went in fairly easily. And I'm going to put this screws in as well, just to hold it in place. solder those guys in place. I think we've got them all soldered in now. Yep. And I should probably put a couple of fuses. Did I put one? Oh, I put one in. That's right. I put one in for test purposes, so I can run it on without a load or with a small load. See how it behaves. Okay, I think we're good to give it a quick test. See what happens on a current limited. Well, 12 volt positive. I'm going to limit this to about 4 amps initially, and see what happens. Get the earth out of the way. Okay, so far so good. No bangs. See what happens when we turn it on. Oh, looks like that's the input voltage. It's measuring 13.2 volts. Output wattage is at 0. So far so good. It's taken about half an amp at this point in time at 13 volts. And everything seems happy. Right now, turn the supply off. Get that heat sensor back in place where it's supposed to be, there, which is actually sensing the one half of the heatsink, which is good. Now we can try a load, just a small load on there, just to see what's going on. So let's plug something in. See what's going to happen with a bit of a load. A little bit of I think that's a. Not sure what that is actually, but we can try it. Okay, let's turn it on. Connect the power would help. It's still fused at 30 amps, but that shouldn't take anywhere near 30 amps right now. Put the current up a little bit. Put it up to about 8 amps, 2 amps. Okay. And it's telling us we're drawing about 10 watts at the moment. Everything seems to be functioning. I don't know whether that fan is on yet, but we could increase the load. Okay, turned it off. Let's put a 150 watt lamp on there. See what that does. It's getting warm. Let's see how we get on with that. Up the amperage a bit. Alright, that's taking about 10 amps. And 80 watts according to the meter. .5 volts and 80 watts, which is, it's actually 150 watt bulb, and seems to be quite happy right now. So looks like it's fixed. Let's turn it off for a minute. So clean the board where I put those MOSFETs in. Let's trim those legs of the MOSFETs because they're a bit on the long side. I'll resolder those now, trim the legs. I guess maybe we can give it another try. Let's plug in a load of some kind. My power supply is only going to give me 20 amps at the most through the 13 volt supply, so let's put the 150 watt and that was say 100 watts, so that'd be 250 watt load if it doesn't go bang. It might overload the power supply as well. Okay, so let's put the power on. See what it does with a 250 watt load. Make sure I've got everything hooked up properly. Alright, wants to take more current than I'm giving it. Wow. Alright, so that's now at 13.9 volts, or we'll call it 14 volts at full amperage, 20 amps. So let's see what that does. Right, so it's taking 18 amps now, Still relatively low load, and the display is saying 170 watts at 12.9 volts. So let's leave it like that for a couple of minutes and see what it does. Seems to be happy at the moment. Nothing seems to be getting too hot right now. These are toasty warm. It's taking a consistent 18 amps at around, well, it's around, it's measuring 12.9 at the input here. Yeah, these leads are getting a bit warm as well. Yeah, I don't want to melt my cables. Alright, well it appears to be working. So what I'm going to do for now is I'll put the rest of the fuses in. I think I'll put it back together. So we've got 1, 2, 3, 4, 5, 6. This needs a good clean as well. I have to take that and give it a good clean. Wash it and clean it. Alright, so let's get serious with this thing. Now I can start putting this all back together again. So in the meantime, I've washed all the parts, and it's come out quite nice. All the parts of the case. So that will allow me to put everything back together. And I think this will go back either way. There's an odd hole there, which looks like it will line up with that hole in the printed circuit board. Oh, maybe not. Aha. Yeah, that looks more like it. Yeah, that way around. Okay. got 1, 2, 3, 4, 5, 6, 7 that hold the printed circuit board down. So I'll start putting those in first. And each one of these has washers with them. We got the 8 for each side, or the 4 for each side. Okay, so this should now fit back here pretty well. There we go. And we've got 5 screws there, but another 5 another 5 for that, plus 4 for that. Alright, so we should have 10. We should have 10 of these, which we've got. So I think I'll start putting these end. Let's put this one in first. Also got to remember this earth connection or ground connection. It might be easier for me to put that ground. No, I can reach it. I can reach it. So let's start putting these in. Should be 10 of these. I think I'll put this ground connection on next. Alright, so let's get this end cap on here. Looks like it goes that way around. And 4 screws, self-tapping screws. Okay. So we've got 8 screws to hold the bottom plate in place, and Let's see. I think I'm going to put it that way on, because, oh, actually no, I'm going to put it that way. There's a key here to make sure you put it in the right way, and that prevents you from putting it on the wrong way around. Well, it just lets you know which way around it should be. Okay, and the last is a couple of bolts. We're back together, and I'm going to test it one more time. Okay, let's power it up with no load, see what it does. Okay, so it's telling me we've got 14 volts, 14 volts and no load. So that seems to be okay. Let's put a load on it. So at 14 volts, 250 watts, it's around 18 amps, if I'm not mistaken. So that's our 250 watt load, and we'll fire that up. Okay, so saying 12.9 volts and about 100, well, it reckons about 170 watts, 160, 170 watts. It's taking about 18 amps, so that's about right. And the cables are getting warm, so I'm going to turn that off. I think we'll call that a fix. That needed 7 fuses, 4 FETs, 4 MOSFETs, and some TLC. Okay, well, thanks for watching. If you enjoyed the video, give me a thumbs up and subscribe for more videos. Thanks again. Bye for now.